Okay, so in the other problem, it says find the relative maximum or minimum of y equals x cubed minus 3x squared plus 4 using the first derivative test and the second derivative test. So these two tests actually will do the same thing, just find the relative maximum or minimum. Okay, they will give you the same values definitely, but one of them can make the process easier. Sometimes the first can make it easier, sometimes the second derivative will make it easier. Okay, so context first, ideas. When we look for the maximum or minimum, again we draw a random graph. Let's make something like this. Okay, so it's a random curve. To the left, it goes to positive infinity. To the right, it goes to positive infinity. So there is no absolute maximum in the graph. When you say absolute maximum, it's the highest value in the graph. If it goes to infinity on both sides, then we cannot identify a specific number, okay, because it's infinity. However, if we consider the minimum, we could consider the point here to be the minimum. And this will be an absolute minimum because there is no point that is lower than that point. That's the lowest. So it's an absolute minimum. Now, if we will relate that to this point, if we will cut the graph on the immediate interval, then the blue point is still a minimum, but it's no longer an absolute minimum, but it's a relative minimum. The reason that the word relative was used because we can actually consider a smaller interval, and in that interval, relatively, that's the minimum value. Okay? Earlier we said as well that there is no absolute maximum, but this point can be considered as a relative maximum. So this can be a relative maximum. The point earlier is a relative minimum. Okay, so those are the ideas in terms of the graph. Now, how will this be related to the derivative? Okay, in every maximum or minimum, the tangent line on those points or on a specific point will be a horizontal line. Here, it's also a horizontal line, and on the third, the tangent line is horizontal. And again, going back to the lines, concepts of lines, when the line is a horizontal line, the slope is equal to, when the line is a horizontal line, the slope of that line is 0. And that's a very important idea to note. The m will be the slope of those tangent lines. The m will be equal to 0. And again, we said earlier that the slope, is the derivative of the curve at a given point. So this will be used every time we look for maximum or minimum. We want to find what values will the derivative becomes or equal to 0. Okay, so we were given a specific curve or function, and that is y is equal to x cubed minus 3x squared plus 4. Okay, so y is equal to x cubed. So considering y equals x cubed minus 3x squared plus 4. To know the relative and a maximum or minimum, we will be using the derivative of this. Okay, let's apply the first derivative test. First derivative test. As the name suggests, we can only use the first derivative. Okay, so how does it work? Step number 1, you get the derivative of the curve. dy over dx is equal to, apply 3x squared minus 6x. The maximum or minimum values can happen when dy over dx is equal to 0. And that's the main idea. So that means getting 3x squared minus 6x, setting that to 0, we will be able to identify the x. And then we just solve this equation by factoring 3x, x minus 2 is equal to 0. So that means 3x could be 0 or x minus 2 is 0. And this will give us two values of x equals 0 and x equals 2. So either a maximum or minimum will happen on 0, and then maximum or minimum will happen at x equals 2. Okay. So how do we identify if it's a relative maximum or minimum? So step number 2. Okay. We will be investigating what is happening with the derivative before 0, between 0 and 2, and after 2. Okay, so how? Note that the derivative, the f prime of x, or the dy over dx, is equal to 3x squared minus 6x. So what are we going to do with this? Let us test first what is happening before 0. So simply put a value on the derivative and see what will happen to its value. Say, give me a number before 0. Negative 1. So at x equals negative 1, so this is 3 times negative 1 squared minus 6 times negative 1. So this is equal to 3 plus 6 equals 9. And we just need to know if it's a positive or a negative number. So before 0, we know that this is positive. And then we go to the next interval, 0 to 2. We do the same process. This time, we check at x equals, give me a number between 0 and 2. 1. Then we repeat the same process. 3 times 1 squared minus 6 times 1. 3 minus 6, or negative 3, a negative number. So in between, it means we have a negative derivative. And then last is a number after 2, say at x equals 3. So 3 times 3 squared minus 6 times 3 is equal to 27 minus 18 and equal to 9, and that's a positive number. So we place on the table, on the number line, a positive sign. Okay, so how do we interpret this information? A positive derivative means increasing. A negative derivative means decreasing. A positive derivative again is increasing. What is increasing and decreasing? It is describing the graph of y or the given function. Okay? So we don't need to graph it exactly, but what we can see, before the 0 it is increasing, after the 0 it is decreasing, after 2 it will go back to increasing. Okay? So as you can see, at 0 it indicates a relative maximum, and then at 2 it indicates a relative minimum. Now, can these points be considered as absolute maximum or minimum? No, right? Because on the left is going to negative infinity, on the right is going to positive infinity. There's no absolute minimum, there is no absolute maximum. So to finally find the points, the maximum points or the minimum points, the relative max and mean, we already know the x. It's x equals 0 and x equals 2. So x equals 0 and then x equals 2. What you need to find are their corresponding y value. Okay? And to find their corresponding y value, you go back to the y. Y is x cubed minus 3x squared plus 4. And get the corresponding values. So y at x equals 0, 0 cubed, 3 times 0 squared plus 4 will be equal to 4. And this means y is equal to 4. But when x is equal to 2, y is equal to 2 cubed minus 3 times 2 squared plus 4. This is 8 minus 12 plus 4, this will be 0. So y is equal to 0. So the points are 0, 4 and 2, 0. 0, 4 as a relative maximum and 2, 0 as a relative minimum. That's how you use the first derivative test. Okay. Okay. What about the second derivative test? The second derivative test. In the second derivative test, you will be performing the same steps 1 and 2. From 1, we obtain dy over dx is equal to 3x squared minus 6x, in which we found x, when this is 0, x is equal to 0 and x is equal to 2. Okay? But the second step, instead of using the first derivative, you go straight to the second derivative. So the second derivative, d squared y over dx squared, that's the notation for the second derivative, this will be equal to 6x minus 6. And immediately you apply the values of x one at a time. We test x equals 0. We substitute 0 on the second derivative, and 6 times 0 minus 6 is equal to negative 6. So how do we analyze it using the second derivative? When the second derivative is negative, it indicates a maximum. And then if we try x equals 2, we have 6 times 2 minus 6. The answer is positive 6, and it will indicate a minimum. So we were able to validate using the second derivative test that at x equals 0 and x equals 2, we could get relative maximum and relative minimum respectively. Okay, so that's how we validate. It should be consistent with the first derivative test. Okay, now what will happen if you get a value equal to 0 when you substitute? In the second derivative test, you cannot make a conclusion. That is the time that you go back to the first derivative test. Okay, did you understand?